Okay, Jordan, we're gonna create our unit circle right now. This is what all the trig functions you're doing right now, where they come from, and how we derive them. So basically, we have a coordinate plane, which you should know what that is from algebra and geometry. A couple of things I want to review are just that this is the y-axis and this is the x-axis. And we know if we want to find the coordinates of a point, we want to find the coordinates of this point, x comes first, then y. And how you find the coordinates of that point is you look to see what this x value is. Let's say it's 3. And you look to see what this y value is. Let's say it's 6. So then your coordinate would be 3, 6. We're going to use that same knowledge to fill out the coordinates of our unit circle. So I want you to keep that concept in mind when we fill out the coordinates of our unit circle. Okay, so you should probably draw this and fill this out with me, what I'm about to do. So I'm going to draw a circle. It's probably going to be kind of bad. It's pretty bad, but it'll work. Hopefully you can see that. I'm actually going to move this over like that. Okay, good. Alright, so we have a circle, and the first thing we want to do before we find the coordinates of points on the outside of our circle here, we're going to fill in the angles first. So let's do that. So the coordinate, this is going to be 0 over here. This is 0 degrees. So if I go all the way here, this would be a 90-degree angle. So I'm going to put 90 degrees here. And if I go from 0 all the way to here, which is half a circle, that's 180 degrees. And then if I go from here all the way to this line, this opening is 270 degrees. And if I do a full circle, we know that's 360. So this is also the 360 point. It's the 0-degree point if I start here, if I go all the way around, 360 degrees. So what we're going to do is actually write the radians too. So we know that, well, 0 degrees is, well, we can do the math. To convert from degrees to radians, what do we multiply by? We multiply by pi over 180. Well, 0 times pi is just 0 divided by 180. You just get 0. So that means there's nothing yet. So we haven't done anything yet. We're going to do the other one. So 90 times pi over 180. You get 90 pi over 180, and you reduce it. You should get 9 over 18 pi, which reduces to 1/2. So pi over 2. We don't always write the 1 over 2. We just write pi over 2. So I want you to go ahead and convert 90, which you just did. This is equal to pi over 2. Also convert 180 and 270 right now. So pause the video and convert those two for me. And then come back when you're done. Okay, so if you converted these, you should get pi and 3 pi over 2. Now, you're actually going to have to convert all of them. So what I mean by all of them is we have more angles. So we're going to actually fill in a whole bunch of angles. So we're going to do 3 angles per quadrant. Quadrant 1, 2, 3, 4. So we have, I think there's 3. Let me see. I forget how many you do. Yeah, there's 3. Okay. We're going to do 30 degrees. So this opening is 30 degrees. How many radians is that? So you have to convert 30 degrees and find the radians. So I'm not going to take the time and do all those. You can pause the video and convert all these if you want to get practice, which you should. But this is going to be 30 degrees, which is pi over 6. This is 45 degrees, which is pi over 4. And then this is 60 degrees, which is pi over 3. Okay, so we're going to do basically this whole circle. So you have the 90 degrees here, then you have 120, 135, 150. So you need to convert all these into radians. 210. 225, 240, 300, 315, and 330. So convert all those into radians for me. Pause the video. I'll put the answers up. Okay, so I've only converted the top half to radians, 2 pi over 3, 3 pi over 4, 5 pi over 6. I'll send you a unit circle via email when we're all done. Because you can just print these offline. You can just print like a unit circle offline, and it looks really crazy like this. But it's really important you know how to derive it, because on tests sometimes you have to fill it out. Or if you're not sure how to do something, if you remember how to fill in a unit circle, you will be pretty much set. So, what we're going to do now is the angle part's pretty easy. You know how to do that. You can convert. That's not difficult. We're going to actually find the coordinate points. So what I mean is, at 30-degree angle, what's this coordinate point? This coordinate point, this coordinate point, all these coordinate points. This is what we need to fill out your worksheet. So we're going to go ahead and do that right now. So this is the main purpose of this unit circle. Okay. So my unit circle is really messy. I'm actually going to erase some things here because it'll make it a little easier for us. But I want you to leave yours as is, or draw another one if you want, if yours is messy. But don't erase it. Okay. So what's really important is to remember your triangles we just went over, and to remember that finding a coordinate point is just x, comma y. In trigonometry, x is cosine, and y is sine. So how do we find those coordinate points? Well, in a unit circle, the radius of your circle is 1. So this is just 1. So this coordinate point here, well, it's hitting the x-axis at 1, and it's hitting the y-axis at 0. So this is 0, 0. So we know that this point right here is 1, 0. So we can fill this point in. We know the y-axis, this is 1. And the x-axis, well, this point hits the x-axis at 0. So it's 0, 1. This coordinate point On the x-axis, this is a -1, and it hits the y-axis at 0. And then this last coordinate point, the y-axis is at a -1, and the x-axis hits at 0. So those four are pretty straightforward. How do we find the other ones? Well, to find the other ones, we actually use our knowledge of triangles. So if I put this line back in and make a triangle here, well, we said this angle was 30 degrees. If this angle is 30 degrees, and this is 90, 180 is what all the angles add up to in a triangle. So 180 minus 30 minus 90 was going to give you 60. We can fill in our circle. Here's why. We can fill in our triangle. The reason we can fill it in, well, let me make sure this is right. Yeah. We know that the radius is 1. So here's the center of my circle. Here's the edge of the circle. We know the radius of the circle is 1 everywhere. We know that's 1. We can fill in the other lengths of this triangle using our knowledge of the 30, 60, 90 triangle. All right. So if the hypotenuse equals 1, well, 1 equals 2 times the shortest side. So 1 equals 2x. I'm going to write that equation. To solve for x, I just divide both sides by 2. So x equals 1/2. So if this hypotenuse is 1, then x equals 1/2. And then 1/2 times, this equals x, this equals 2x. If x is 1/2, then I can do 1/2 times the square root of 3 and plug 1/2 in here. So if I do 1/2 times the square root of 3 over 1, I get the square root of 3 over 2. So that means my hypotenuse is 1. Because my hypotenuse is 1, I could solve. We know that this hypotenuse equals 2 times x, the shortest side. So I set up an equation, 1 equals 2x, solve for x. Since x is the shortest side, I plugged 1/2 in for x. And then this side across from the 60-degree angle is x times the square root of 3. So I plug my x in, 1/2 times the square root of 3, and I get square root of 3 over 2 for this side, and 1/2 for this side. Perfect. All right. So we have filled out the lengths of my triangle. Solve for the coordinate of this point, because we know the coordinate of the point is just x comma y. So my x length, this length, is square root of 3 over 2. And my y is 1/2. This hits the y-axis at 1/2. That is my coordinate for that point. And so that's how your coordinate points are derived, and you could actually do the whole circle that way, and we're not going to because that would take forever. But you are capable, you have the knowledge to do that. We're just going to do the first quadrant, and then we're going to fill in the rest with a shortcut. So we found the first coordinate point. Let's do the second one. The second one, if you remember, this one is a 45-degree angle. And so we have a 45, 90-degree triangle. And so the rule we learned in geometry was it's x square root of x times the square root of 2. Well, we know what this length of this hypotenuse is, because the radius of the circle is 1. So we know that the hypotenuse equals 1. So we can solve for x. 1 equals x square root of 2. We divide both sides by the square root of 2. We get x equals 1 over the square root of 2. Now the problem is we can't leave answers with a radical, a square root symbol in the bottom, in the denominator. We can't do that. So we have to multiply this by the square root of 2 over the square root of 2. So to get rid of this square root in your denominator, you just multiply the entire fraction by the denominator over the denominator. When you multiply a square root by itself, the square root symbol goes away, you just get 2. Right? Here's why. The square root of 2 times the square root of 2 equals the square root of 4, because 2 times 2 is 4. With the square root of 4, you just go ahead and take it, and you get 2. 1 times the square root of 2 is 2. So we just simplify that, and we get the square root of 2 over 2. So x equals the square root of 2 over 2. I can go ahead and fill that in. So the coordinates for this point, well, it hits the x-axis at this distance is square root of 2 over 2. And hits the y-axis at, well, this distance is square root of 2 over 2. Bam. Done with that coordinate point. We're going to do the last one, and then we're going to fill in the rest of the circle really quickly, because this is, I know it's taking a while. But it's really important you know how to do this. If you need to watch this video a few times or pause it, you should do that, because this is the foundation of trig. I usually spend like multiple weeks on this, so it's unfortunate I'm like flying through it, but I think it's okay. So you can always ask me more questions, or you can tell me this was super confused. I need you to go through it slower too. So the last one, this was 60 degrees. So this must be 30. So we have a 30, 60, 90 again. So I wonder what's going to happen here. We should get something similar to this, because this was a 30, 60, 90 triangle too. So we know across from the hypotenuse, or this hypotenuse length, we know the radius is 1. So we know that this equals 1. That distance is 1. However, we also know using our geometry rule that the hypotenuse equals 2 times x. So if 1 equals 2 times x, we can solve for x again. Divide both sides by 2. X equals 1/2. Well, across from the 30 degree is supposed to be x, the shortest side, so we can plug in 1/2. And then across from the 60 degree is x square root of 3. So we can plug in x right here, 1/2 times the square root of 3. You just get the square root of 3 over 2. Okay, so now we can find our coordinate point here. Our x length, this length for the x, hits the x-axis here at length 1/2. And it hits the y-axis over here. This length, this distance, is square root of 3 over 2. So notice it's the same as this coordinate point, but the x's and the y's were flipped. All right, we just finished this first quadrant. We filled in the coordinate points. I'm going to teach you now how to do it for the other quadrants. Now, you could do the exact same thing over here. And here's why. So if you remember, this was 150 degrees from the start. But 180, this line 180 minus 150, well, that means this angle is 30. So to find this coordinate point, we can yet again do another 30, 60, 90 triangle. But we already know the answer to that. We already know that if it's a 30, 60, 90 triangle, it's going to be the same as this. Square root of 3 over 2, 1/2. So across from the 30, we have the square root of 3 over 1/2. Across from the 30, we have 1/2. Across from the 60, we have the square root of 3 over 2. And we know the radius is 1. It's the exact same triangle we had over here. The only difference is, remember, your x's and your y's in this quadrant are both positive. But in this quadrant, your x's are negative. These are negative values, right? These are negative values. This is a negative 1 over here. So this happens to be a negative square root of 3 over 2. And a positive 1/2. These are positive y's. So we can actually fill in the rest of our circle, and we just have to change the signs because we're in different quadrants on our coordinate plane. So I'm going to go ahead and do that with you right now. So they're going to be the exact same coordinates for these 3 points. And they're going to be the same down here too. Okay. The only thing we have to do is figure out the signs. So in this quadrant, all of the coordinates are positive. Positive, positive. In this quadrant, the x's are negative and the y's are positive. So I'm going to make all the x's negative. In this quadrant, quadrant 3, the x's are negative and the y's are negative. So these all need negative signs. In this quadrant, the x's are positive and the y's are negative. So these all need negative signs. That's your unit circle, and I will email you an actual unit circle you can, print off and keep. But it's really important you understand like how these were derived, sort of, and you can understand that this x is cosine and this is sine. Now, in an ideal world, you will have a unit circle that has your degrees and your coordinate points on the same one. That's a perfect world. So it's really messy, so I didn't include everything in this one. But when we go to fill out your worksheet now, it's important that you have all of them. So let's look at your worksheet. Now your worksheet, actually I'm going to stop this video and start another one, and then we'll do your worksheet.